Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. And today's topic is Heisenberg uncertainty principle. What is that? Heisenberg uncertainty principle. So, this principle is consequence of dual behavior of matter and radiation. Already we have studied that. According to de Broglie, matter not only has particle nature, it also has wave nature. That means dual nature. Dual nature means two natures. So, according to Heisenberg, it is said that it is impossible to determine at the same time, simultaneously means at the same time, the exact position and exact momentum or velocity of an electron. That is Heisenberg uncertainty principle. At the same time, we cannot calculate the exact position and exact momentum of an electron. That is what Heisenberg uncertainty principle is. It is impossible to determine both the position and momentum of an electron simultaneously and accurately. This is another way of saying Heisenberg uncertainty principle. Okay. Right. So let us see. Here, here is electron. Electron moving. This is an atom. In this atom, energy levels, right? Here is the electron. If we want to know the position of the electron, for example, what we need to know? We need to know the position. If we need to know the position, knowing the position means we have to measure the position. If you need to measure it, we should have an instrument which is able to measure this, and that instrument should possess readings. Okay. So, for example, here we need to measure the position of electron. If we want to measure the position and velocity at the same time, first of all, we need to observe it. To observe this electron, we have to illuminate it with light having wavelength smaller than the dimension of the electron. Actually, electron is a point charge. We say that it is dimensionless. Okay. Electron is a point charge. Considering point charge, if we consider a point, then if we want to measure this, then what we are doing is we are focusing light on it, illuminating light on it. This light is having wavelength. See, light is having wavelength smaller than the electron. Okay, so to observe an electron, we can illuminate it with light having wavelength smaller than dimension of the electron. Okay, so we are focusing a light to observe the position and velocity of this electron, and we are illuminating electron with a light having wavelength smaller than that of the electron. So, and we know that E is equal to energy of the photon is equal to hc by lambda. If lambda is very small, energy will be very high. Lambda is small, energy will be very high. If such a high energy photon is made to fall on this electron, that high energy is absorbed by the electron, and within no time, within fraction of time, as it is absorbing energy, it will change its velocity. So this high momentum photons of such light would change the velocity. So we can calculate position. Position can be calculated. But what about velocity? Velocity, as it is absorbing energy, the velocity changes. Velocity changes, and this velocity will be uncertain. As velocity is changing, see, this photon after colliding this electron, as this electron takes the energy, and after collision, velocity of electron cannot be calculated exactly. Velocity is changing. So, if you calculate velocity, velocity calculated will be error. There will be error in this velocity calculated. So, if one property, that is if position is calculated with some accuracy, then velocity cannot be calculated accurately. There will be error in velocity. In the same way, if velocity is calculated with some accuracy, then position cannot be calculated. There will be error in the calculation of position. That is what it says. So both position and velocity of an electron cannot be calculated at the same time exactly. So there will be some error if one property is calculated with some accuracy, then the other property calculation will be error. Okay, so that error is simplified or see, uncertain. Uncertain means not certain. There will be some error in its calculation. That is called as this uncertain. Okay. So this principle is mathematically represented as what? That is what? Delta x into delta p is greater than or equal to h by 4 pi. See, delta x into delta p is greater than or equal to h by 4 pi. What is delta x? It's called as uncertainty in position of electron. Uncertainty in position of electron. Generally measured in meters. Units, what are the units? SI unit, meter. Delta P, what do you say? Uncertainty. Uncertainty, already said that it is error. Uncertainty in momentum of electron. Okay, so delta P can also be written as m into delta V. First you can write as delta P is equal to delta into mv, that is equal to m into delta V plus V into delta m. As mass is constant for this electron, that is equal to m into delta V. Delta mv is equal to, understood, plus 0. So delta P can also be written as what? M into delta V. M into delta V. So again writing Heisenberg uncertainty principle, delta x into m into delta v is greater than or equal to h by 4 pi. Okay, then what is delta v? Error in velocity, or we say that the uncertainty in velocity. Uncertainty in velocity of electron. Measure units of velocity gives you meter per second square, right? So meters per second. What are the units of velocity? Meter per second. Okay. Right. So delta x into m into delta v is equal to h by 4 pi greater than or equal to h by 4. So in calculations we use only equality, right? For example, if delta x with the position of the electron is determined as delta x is equal to 0. So position is determined. How is position determined? Let us take delta x is equal to 0. It is determined as delta x is equal to 0. So there is some precision, accuracy in the measurement of position. Then what will be delta v? What will be delta v? So delta v is equal to h by 4 pi m into delta x. That is equal to h by 4 pi m into 0. Delta x is equal to 0, no? Then that is equal to h by 0. Anything by 0 is equal to infinity. So when delta x is equal to 0, then delta v is infinite. That means if delta x means error in the position is 0. Error in the position is 0. That means we have calculated exactly or accurately. That means error in position is 0. Then error in velocity will be infinity. That means there is large error in velocity. In the same way, if error in velocity is equal to 0, then error in position will be h by 4 pi m into delta v. Then again we get h by 0. This is equal to infinity. If we exactly calculate the velocity, then the error in the position will be infinity. So if one is having less error, other will have more error. If one is having less error, other will be having more error. Right? So both the position and velocity cannot be calculated exactly at the same time. That is what Heisenberg uncertainty principle says. Okay. Here if you see, delta x into delta v is inversely proportional to mass of the particle. Mass of the particle. Inversely proportional. Then automatically, if two particles, if A and B are two particles, if you consider two particles, then delta x into delta v of particle A by delta x into delta v of particle B will be equal to mass of particle B by mass of particle A, because this delta x into delta v is inversely proportional to mass. Then if masses are given and the relation between these two particles, delta x and delta v, relation between these two particles will be inverse of their masses. Okay. So that is about the definition and mathematical representation of Heisenberg uncertainty principle. Let us go with significance of Heisenberg uncertainty principle. What is that? Significance of uncertainty principle. What is the significance of uncertainty principle? See, the trajectory of an object is determined by its location and velocity at various moments. So here is an atom. In this atom, electron, for example, here is electron. If its location and velocity, what is that? Location and velocity is, for example, it is location and velocity. And at different various moments it is set. After some moment, we find that its location is something like here. After some time, its location and velocity is something like here. So if both location and velocity of a particle is determined at different moments, then we can find the trajectory. Trajectory means the path or the direction in which the electron is moving. Okay, so that's called as what? Trajectory. The path in which the electron is moving. Path means only direction in which the electron is moving. That is what Niels Bohr says. Niels Bohr said that electron moves in definite path, circular paths. Definite circular paths, because according to Niels Bohr, electron is behaving like a particle and its location and velocity at different moments can be determined, so that Niels Bohr said that there is a particular trajectory. It is moving in circular path. It is moving in circular path. But from Heisenberg uncertainty principle, the subatomic particles like electron, it is not possible to determine simultaneously both position and velocity accurately. According to Heisenberg, position and velocity cannot be calculated accurately at the same time. As position and velocity cannot be calculated accurately at the same time, then how can we say, we discuss about the trajectory? So from Heisenberg uncertainty principle, it is said that as position and velocity of an electron cannot be calculated accurately at the same time, we cannot discuss about the trajectory of this electron. Trajectory of this electron. So from that, he says that this point is very important. It rules out. That means there is no existence of definite paths or trajectories. There is no definite path. So the definite path concept was given by whom? Niels Bohr. From the Heisenberg uncertainty principle, he says that there is no definite path. There is no trajectory of electrons and other similar particles like that of electrons, subatomic particles. So this point is very important. What does he say? There is no existence of definite paths or trajectories. Next, Heisenberg uncertainty principle is applicable for only microscopic particles. Applicable only for microscopic particles. It is not applicable for macroscopic particles. Because for macroscopic particle, both position and velocity can be calculated accurately at the same time. So for example, there is a bus moving. That is a macroscopic particle. Its position can be calculated, at the same time its velocity can also be calculated accurately. So for macroscopic particle, Heisenberg uncertainty principle is not applicable. Whereas for microscopic particles only it is applicable. Microscopic particle like electrons, it is applicable. So let us calculate delta x into delta p for so delta for electron, let us calculate delta x into delta p is equal to h by 4 pi, greater than or equal to, but calculating when it is equal. So delta x into delta p will be equal to 6.626 into 10 power minus 34 joule into second by right 4 into 3.14. Let us calculate delta v. So mass of an electron is 9.11 into 10 power minus 31 kg. Then what do we get? If we calculate this, we get right. To calculate this, we get 10 power minus 4 meter square per second. What is this, sir? Delta x into delta v. Okay. See, the uncertainty principle is mainly applicable for an electron. So for an electron, let us take, now we have calculated that delta x into delta v is equal to 10 power minus 4 meter square per second. If in uncertainty is in position is of only 10 power minus 8 m, for example, given what delta x is equal to 10 power minus 8 m, then what will be delta b? How much? We know that delta x into delta v for an electron we have calculated as 10 power minus 4 meter square per second. Then what will be delta v? Delta v is equal to, okay, 10 power minus 4 by meter square per second by delta x. What is delta x given? 10 power minus 8 meters. Okay. Then what you get? 10 power plus 4 meters per second. Delta v. See, here delta x means what is error? Simply remembering that it is error. Error in position is very much less, 10 power minus 8. Then what will be error in velocity? Error in velocity is very large. How much? 10 power plus 4. So if error in position is very less, error in velocity will be very huge. From this also again we confirm that both position and velocity or momentum cannot be calculated accurately at the same time. This is what Heisenberg uncertainty principle is all about. Okay. So let us meet in the next lecture. Thank you everyone. Right.